Okay, let's start. So today we start implicit differential functions. Okay, in the study of one variable functions, we had considered implicit differentiation, and it was like this in the study of one variable functions. We studied implicit differentiation. What was that? It was like this. Suppose y equals f of x is given implicitly by an equation of the form f x y equals 0. Yani y'nin açık ifadesi yok. We don't have explicit expression of y as a function of x, but instead we have this implicit definition of the function. For example, suppose this x squared y minus e to the power xy minus cosine y equals and plus 5, let's say, equals 0. Something like this, okay? Here, y can be solved in terms of x, but, finding an explicit formula for y may not be possible, okay? For example, in this case, I don't know what is y equals f of x, okay? Since these are analytic functions, we may try to write down expressions for y, but even in that case, it will not be that easy. However, theory tells us the following. So theory implies what? If del f del y at some point x0 y0 is not equal to 0 for some x0 y0 with f of x0 y0, then f is equal to y is equal to f of x for some function f. Bu ne demek? Yani bu şöyle bir şey. This, if you equate f of xy equal to 0, so this equation, this has a solution set. It may be something like this, and then there might be something like this here, okay? So this whole thing may not be the graph of a function. However, if we have some x0 and y0 satisfying this equation f xy equals 0, and if this derivative is not 0, then theory tells us the following around şöyle yazayım x0 y0. Teori bize şunu söylüyor. O zaman diyor ki then there are open sets like this, okay? intervals so that y can be written in terms of x as a function for x in this interval. Let's say x0 minus delta, x0 plus delta. There is this interval, delta interval. Okay. Ve dahası moreover of course here I assume f is differentiable. Moreover, f of x is differentiable. And thus şunu yapabiliriz. Yani differentiable olduğu için taking derivative of, şimdi f(x,y) 0 ya, f(x,y) y is a function of x, so I have this. Therefore, this whole thing is a function of x, right? This is a function of x, this is a function of x, and in this case we get the following. Taking derivative with respect to x, we get that f sub 1 x, f sub x plus f sub 2 x, f of x, f prime x equals 0. Değil mi? Çünkü bunun türevini alırsam birinci değişkene göre türev alıyorum. I take derivative with respect to the first variable and then derivative of the first variable with respect to x, which is 1, plus derivative of f with respect to the second variable times the derivative of the second variable with respect to x. And from this we get f prime x is nothing but minus f sub 1 x f of x, f sub 2 x f of x. Or, you know, I have this f sub 1, f sub 2, xy. Okay. This actually holds more generally, not just for two variables here, but if there are more variables, it is still true. Indeed, this holds more hold for functions of several variables also. Nasıl? Şöyle. Bakayım, onu teorem olarak mı veriyor? Yok. Şöyle diyeyim. Suppose we are given an equation in the variables x, y, and z as follows. Diyelim ki şöyle bir denklem verilsin. İşte f, x, y, z eşittir 0. Tamam mı? Şimdi we have three variables in one equation. What would you expect? You know, a special case, suppose something like this you have 5y minus 2z equals okay, plus 7 equals 0. So if it was like this, then we would solve any of the variables in terms of the other ones. For example, we could just write this, right? this is 3x plus 5y plus 7 over 2. So in this case, we could write z as a function of x and y. We could solve the equation for one of the variables in terms of the others, right? So here we write z. We can solve this equation for z in terms of the other two variables, which are x and y. Of course, for this special case, I could write x also in terms of the other variables, right? What would be this? It would be 2x minus 5y minus 7 over 3 and so on. So what is the general rule in this case? Well, actually, the statement is similar to what we had over here. What was the condition here? Uh, the derivative of the function with respect to the variable, so that you want to write this variable in terms of the other variables, shouldn't be 0. If it is not 0, then you can write, you can solve this equation fxy equals 0 for the variable y. Yani bu denklemin hangi değişkene göre türevi 0 değilse o değişkene göre o değişken için denklemi çözebilirim. Yani işte y'ye göre türevi 0 değilse y eşittir fx diye çözebilirim. Mesela şurada çözemezdim bunu. Niye? Here, for example, at this point, I couldn't solve this like this. Why is that? Because the derivative with respect to y in this case would be 0, right? This is the y-axis. So tangent line is like this. Derivative of y. So if I just see this upside down as if this is the y-axis, the tangent line would be parallel. Therefore, the derivative with respect to y is 0 in this case. If it is 0, then this theory doesn't guarantee that you can solve the equation for y. Indeed, you see, burada, in this case, y is not a function of x. Why is that? Because if this is x0, in any neighborhood like this gadget is not a function of x because uh, for any x value here, there are two y values. So it is not a single valued function. Değil mi? Bu bir fonksiyon grafiği değil. Şu noktanın yakınında. Around this point, this graph is not a graph of a function. Because for any x value, there are two y values. But if it were a function, then there would be only one y value. So that's the problem. Okay. And the same thing holds here. Same thing holds here. Namely, so the fact is this. Suppose we are given like an equation like this. If f sub z, if f is differentiable, okay, and del f del z x0 y0 z0 is not 0 at some point, then there is a disk around the around x0, y0 and a function uh, fxy defined on D so that uh, fxy is 0 for all xy in D. Yani ne demek? In other words, z fxy is a solution of fxy z on D. Yani şöyle bir şey. Eğer bu türev işte bir x0, y0, z0 noktasında 0 değilse f'in türevi, o zaman bu x0, y0 şöyle diyeyim. Şu noktanın civarında şöyle bir tane disk var. Öyle ki bu diskin üstündeki her nokta için bu bir de fonksiyon var. fxy diye. Zxy bu denklemin çözümü. Yani başka bir deyişle f, x, y, z eşittir 0 denkleminin şöyle bir çözümü var. Tamam mı? Bunu söylüyor. Ama f'in açık ifadesini bulamayabiliriz. Yani o f'in ifadesi nedir? Onu açıkça yazamayabiliriz ama there is such a function. Moreover, taking del x and del y of the above equation, we obtain şöyle. Şimdi şu denklemi aldık. Teori diyor ki eğer bu f differentiable ise o zaman bu küçük f de differentiable'dır. If f is, big f is differentiable, small f is also differentiable, and taking derivative, we can compute the derivatives of this. How? Well, take derivative of both sides. Del x of x y, f of x y equals 0. Değil mi? Bu 0 olduğuna göre, since this is equal to 0 for all xy in D, we have this. So del x f x y, f of xy is equal to 0 because this function is 0, therefore its derivative is 0. What is the derivative? Derivative is this. I apply chain rule, derivative of f with respect to the first variable, and then derivative of the first variable with respect to x. The first variable is x, therefore derivative of the first variable with respect to x is 1. And then derivative of the function with respect to the second variable times derivative of the second variable with respect to x plus derivative of f with respect to the third variable times derivative of the third variable with respect to x equals 0. However, this is 0 also. Why is that? Because x and y are independent variables, right? Independent variables. since they are independent, the derivative of one of them with respect to the other one is zero, değil mi? Yani y'nin x'ten haberi yok ki, değil mi? X değişirse değişsin. Hani y sabit. O yüzden bu sıfır. From this we see what? By assumption we assume that derivative of f with respect to z is not zero. Değil mi? Yani şu we assume that this is not zero. It means derivative of f with respect to the third variable is not zero. Okay, so this is not zero by assumption. Hence, we see that del f del x is equal to what? Burası sıfırdı. So this is zero. So this term is gone. I have just f sub 1 minus f sub 1 xy f of xy divided by f sub 3 xy f of xy. Or I can just write it this way. F sub 1 xy z f sub 3 xy z. Okay. If you wanna compute this derivative, let's say at the point x0, y0, that would be just x0, y0, z0, x0, y0, z0. Similarly, of course, this is derivative with respect to x. I could just similarly del f del y x0 x y z would be just minus this time yani x here in this case taking derivative we take derivative with respect to x. In the other case we would take derivative with respect to y, and I would have del x del y here and del y here. Del y would be 1 here, but del x del y would be 0. So this term would vanish, and this would be minus f2 divided by f3. Okay, so I would have just the following. F2 x y z divided by f3 x y z. Okay. Örnek yapalım. Aa, şöyle diyeyim. Okay. Suppose a function z equals f of xy is given implicitly as şöyle verilsin. Dur bakayım şuradan aslında. Okay. Tamam, güzel bir örnek yapayım diyorum ama şöyle diyeyim, x square Yok, şöyle olsun. Şuradan bir tane yazayım. E to the power yz minus x square z ln y equals pi. Okay. Şimdi bunun üstünde bir bir koysak bir koyunca tamam, buradan ne çıkıyor? E üzeri z ln pi. Okay. Find the equation of the tangent plane to the surface given by above equation at the point 1 1 ln pi. Şimdi f x y z is this function e to the power yz minus x square z ln y minus pi equals 0. Okay. Uh, Now this thing has a graph in space, in 3 space, and we are asked to find the tangent plane to this graph at the point 1 1 ln pi. Note that 1 1 ln pi is equal to what? It's a solution of this because this is e to the power 1 times ln pi minus x square z. Okay, x square is just 1 square, z is just ln pi, and no, yeah, ln pi, and then ln 1 minus pi. Ln 1 is just 0, so this is just e to the power ln pi minus pi. But e to the power ln pi is also pi, so this is pi minus pi, which is 0. Therefore, this point is on the surface. So this is a surface something like this, you know. Yani şöyle çizeyim. Bu değil ama bunun gibi bir şey. And we are given a point here, 1 1 pi, 1 1 pi, and we have tangent surface, tangent plane to this surface. Okay, and we are asked to find the equation of the tangent plane. How can we do this? Well, you see, first I have to, if I can write this function z given implicitly by fxy z equals 0 like this, then I can just write down the equation of the tangent plane. All I need just one point and the normal vector. We know that the normal vector in this case would be what? F sub x, f sub y, and minus 1, right? And I have already 1 point, 1 1 ln pi, so I would just write down the equation. But I need this derivatives. Okay, so this point is 1 pi. I need to find this derivatives. Well, uh, for this equation to be solved in terms of x and y as a function of x, z, I need to have that del f del z shouldn't be 0. So let's see, note that del f del z is equal to what? Well, this is just e to the power. Burada yani f'i 3 değişkenli fonksiyon gibi görüp z'ye göre türev alıyorum. Nedir bunun z'ye göre türevi? This is y times e to the power yz minus derivative with respect to z x square ln y minus pi, derivative of pi is just 0, and del f del z x0 y0 z0. So del f del z 1 ln pi nedir bu? 1 çarpı e üzeri ln pi eksi x kare, pardon, 1'in karesi çarpı ln 1. ln 1 is just 0, and this is just pi, right? And pi is not 0. Hence, there's a function uh, fxy, so that uh, defined near x0 y0, so that f x y f of xy is equal to 0.